Today, we're looking at adding and subtracting radical expressions. Your essential question is, how do I add and subtract radical expressions? Your learning intention, I'm learning to perform arithmetic on radical terms. You've got four warm-up questions. So pause the video and do those warm-up questions now. Well, I do hope you paused and that all you're doing now is checking your answers. So if I look at the square root of 36, I notice from my multiplication tables that 36 is 6 times 6. So the square root of 36 will be 6. But it will also be that positive or negative 6. Positive is your primary. Negative is your secondary square roots. What about 48? Let's do our ladder division. 48 is divisible by 2. 48 divided by 2 is 24. 24 is divisible by 2. 24 divided by 2 is 12. 12 is divisible by 2. 12 divided by 2 is 6. The factors of 6 are 2 and 3. 3 is prime, so when I factor out 3, I get 1. When I have 1, then I am done. Let's pair it up. I've got a pair of 2's. I've got a second pair of 2's. So this is 2 times 2 square root of 3, which is 4 square root of 3. Once again, we have our primary, which is our positive, and our secondary, which is our negative. So the answer is positive or negative, 4 square root of 3. If you were still struggling, see if you can pause the video and do the square root of 72 on your own. If not, if all you're doing is checking, let's do that ladder division and see what we get. So 72 is divisible by 2, I get 36. 36 is divisible by 2, I get 18. 18 is divisible by 2, I get 9. 9 is divisible by 3, I get 3. 3 is prime. When I get to 1, I am done. Let's find our pairs. A pair of 2's and a pair of 3's. And I've got this 1, 2 here that is left over. So this becomes 2 times 3 square root of 2, 6 square root of 2. Once again, we've got our primary, which is our positive, and our secondary, which is our negative. What about the last one? The last one we threw that pesky little m to the third power in there. Step 1, we do our number. Okay, 512 is divisible by 2. 512 divided by 2 is 256. 256 is divisible by 2. I get 128. 128 is divisible by 2. I get 64. 64 is divisible by 2. I get 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. I get to 1 and I'm done. That leads me to believe that maybe 512 is a perfect square, and I'll check that out. It's not. That means I've got a square root of 2 left over. Let's pair it up. 1 pair, 2 pairs, 3 pairs, 4 pairs, and 1 left over. So this becomes 2 times 2 times 2 times 2. I've got the square root of 2 left underneath. But what about m to the third? That's equal to m squared times m. Well, with m squared means I can bring one m out, and this one will stay underneath. It's m squared, 1 comes out, this one stays underneath. 2 times 2 times 2 times 2. 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. M square root 2m. Remember, we have a positive and a negative. We've always got the 2, the primary and the secondary. So, positive or negative 16m square root of 2m. And that takes us to today. Now, remember, when we are adding and subtracting terms that have a variable in it, we can only add and subtract the ones that have the exact same variable to the exact same base to the exact same exponent. To add and subtract, they've got to look exactly the same. The same holds true with our square roots. To be able to add or subtract radical expressions, you must have the same, it's called a radicand, which is a number underneath the radical sign. So let's look at the first one. I am looking at that number underneath the radical. Is it the same? Yes. So I will just simply add 3 plus 4, square root of 6. That means it's 7, square root of 6. You add those numbers in front. Can you do the next one on your own? Step 1, are those radicands the same? Yes, they are. Now what? Use your coefficients. So this becomes 8 plus 5, square root of 2, which is 13, square root of 2. Does it matter how many terms we have? No. So I've got all 3 have the same radicand. I'm focusing on what's in front. So this becomes 7 plus 10 minus 4, square root of 5. 7 plus 10 is 17. 17 minus 4 is 13. 13 square root of 5 once we get it simplified. If you're not understanding, back it up and look at this part again. So, is subtracting any different? No. You still have to have the same radicand to be able to combine. If I'm looking at the first one, I've got square root of 3, square root of 3, it is the same. So I focus on 8 minus 15, square root of 3. 8 minus 15 is negative 7, square root of 3, and that is my answer. Pause the video and see if you can do the next one on your own. I hope you tried. Step 1, do they have the same radicand? Yes. I focus on my coefficients. So this becomes 48 minus 35, square root of 21. 48 minus 35 will give me 13, square root of 21. And we're done. Okay, what about the next one? Step 1, do we have the same radicand? No, we do not. Guess what? It is simplified. We can do no more. So this is 48 square root of 2 minus 35 square root of 3. We cannot combine. We cannot do anything else. It's simplified. So what about if the radicands are not the same? Step 1, simplify that radical expression. Then combine the like terms by addition or subtraction. If they've got that same radicand, then they are like terms. Let's look at the first one. We know that the square root of 3 is simplified. But what about 12, the square root of 12? 12 is, divide by 2, I get 6. Divide by 2, I get 3. 3 is prime. 1, and I'm done. So this is 2 square root of 3. This becomes negative 2 square root of 3 plus 3 square root of 3. Combining those coefficients, I'm taking negative 2 plus 3 square root of 3. Negative 2 plus 3 is negative 1. I don't need to put the negative 1 there. I just put negative square root of 3. Can you simplify the square root of 27? So if I'm looking at this 27, and I'm doing that prime factorization, that ladder factorization, I can divide by 3, I get 9. I can divide by 3, I get 3. Divide by 3 one more time, and I get 1. 1, and you're done. I have one pair of 3s, then I have a 3 left over. So this becomes 5 square root of 3 minus 3 square root of 3. Looking at those coefficients, 5 minus 3 square root of 3. 2 square root of 3. Okay, for the last one, once again, does it matter how many radicals we have? No. You still have to simplify all of them. So if I'm looking at this, I've got to simplify 18, radical 18. So 18 is divisible by 2, I get 9. Divide by 3, I get 3. Divide by 3, I get 1. So 2 square root of 18 is equal to 2 times 3 square root of 2. 2 times 3 is 6. This becomes 6 square root of 2. Can I simplify the square root of 12? Yes. 12 is 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. So 8 square root of 12 is equal to 8 times 2 square root of 12. And that would be square root of 3. Sorry about that. 8 times 2, square root of 3, 16 square root of 3. Minus. What about the square root of 27? 27 is, divide by 3, I've got 9. Divide by 3, I've got 3. Divide by 3, I got 1. I've got that one pair of 3s. So, 4. Square root of 27 is equal to 4 times 3 square root of 3, or 12 square root of 3. Okay, which ones can I combine? Can I combine all 3? This one has radical 2. I cannot combine it with a radical 3. So this is 6 square root of 2 plus 16 minus 12 is 4 square root of 3, and I am done. How do you know when you're successful? You know you're successful when you can add or subtract radicals. Must have the same radicand. To add or subtract. You can also think about fractions, how you have to have that same denominator to add or subtract. But when you get into multiplying and dividing, it's not the same. So remember that as we go on with our how we use the arithmetic on radicals.